Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. Here is the list of properties of the greatest integer function. As we know, according to the definition of the greatest integer function, greatest integer is less than equal to x. And it is also given that it is greater than x minus 1. For example, if x is equal to 2.9, then what is the greatest integer? The greatest integer is 2. And if we want to check property, then we can write here 2 less than is equal to 2.9 and less than 2.9 minus 1, it is 1.9. It is true. Means this property is always true. Property number B, if m is integer, then x plus minus m, greatest integer is equal to greatest integer x plus minus m, where m is integer. Suppose here is the 2.3 plus 4, then your answer will be greatest integer 2.3 plus 4, it will be 2 plus 4, your answer is 6. In same condition, if we find the summation of these two numbers, it is the 6.3 and the greatest integer of 6.3 will be 6. Means this property is true. There is one more property, greatest integer of x plus y lies between two successive integers. Okay. Now, one more interesting property is here. What is the meaning of minus times of greatest integer x? This is interested. Minus type of greatest integer x can be categorized into two parts. If x is not belongs to integer and x belongs to integer. If x is integer, then this is equal to minus times of greatest integer x. What is the meaning of this? The value of minus 3 greatest integer is equal to minus of greatest integer 3, and you can say it is minus 3. And as we know, the greatest integer of minus 3 is minus 3. What is the value of greatest integer of minus 2.9? By the definition of the greatest integer function, it is equal to minus 3. Now, if we want to relate with the minus greatest integer x to the greatest integer function, then what will happen? In this case, minus greatest integer x is equal to minus of greatest integer x minus 1. What is the meaning of this? If x is minus 2.9, or you can say 2.9 for this example, then it is the minus times 2.9. As we know, the answer is minus 3. And by this definition, it will be minus of 2.9 minus 1. As we know, the greatest integer 2.9 will be minus 2, and the value will be minus 2 minus 1 is equal to minus 3. So we can write here, in this category, it will be minus of greatest integer x minus 1. Now, if we want to add this system, then there is also two categories. One is for x belongs to integer and one is for x not belongs to integer. If x is not belongs to integer, then we can use this definition, and if we want to add greatest integer x in this system, the answer will be minus 1 here, and for this system answer will be 0. We can write a property E also like this: greatest integer x minus times of greatest integer minus x, and by above discussion we can say that if x belongs to integer, then your answer will be 2 times of greatest integer x, and if x is not integer, then your answer will be 2 times of greatest integer x plus 1, because the minus times of greatest integer x is equal to the minus of greatest integer x minus 1, and applying this minus sign, the answer will be this. Now we are going to make a list of the properties of the greatest integer function, because this is the most important function. You can recall all the properties one by one. Property number A, B, C, D and up to J. Now we are going to discuss about the property number h. It is the most important property. X plus 1 upon n greatest integer plus x plus 2 upon n greatest integer up to x plus n minus 1 upon n is equal to nx. On the basis of this property, we can solve some examples also. Here is an example. Find the value of 1 upon 3 plus 1 upon 100 dot 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 plus 1 upon 3 plus 99 upon 100. If we check the previous property, n is the 100 and x is the 1 upon 3. What will be the answer? It is the nx greatest integer. What is the n? The value of n is 100. And what is the x? X is 1 by 3. Your answer will be greatest integer of 100 by 3. It is 33.3. Your answer will be 33. Means by using the property, we can solve this type of questions very easily. So I request to you, please memorize all the properties of the greatest integer x. Now further, we are going to list it some inequalities of the greatest integer function. Inequalities are listed here. What is the meaning of this? Suppose question is arising like this. Greatest integer x greater than is equal to 2. What will be the value of x? X will be greater than is equal to 2. What is the meaning of this? If we put x greater than or equal to 2 means 2, 2.1, 3, 3.9, etc. Then the value of greatest integer will be always greater than 2. It is so obvious because for the 2, the greatest integer is 2. And for these all values, the greatest integer is always greater than or equal to 2. Students, now one question is here. Greatest integer x greater than 3. What is the meaning of this? Means greatest integer will be 4, 5, 6 and so on. The value of x for this system should be greater than or equals to 4. It is so obvious. Student, now we are going to take one more interesting questions. Let you have to find the domain of under root greatest integer x minus 1 plus under root of 4 minus greatest integer x. This is the fx and you have to find the domain of this system where it is given that this is the GIF. Now as we know, within a root, function is defined only when function should be greater than or equals to 0. That's why you can say greatest integer x greater than or equals to 1. And for this, 4 minus greatest integer x should be greater than or equals to 0. Implies greatest integer x should be less than or equals to 4. Now what is the answer of greatest integer x greater than 1? If greatest integer x greater than 1, then x should be greater than equals to 1, or you can say from 1 to infinite. And for this system, greatest integer x less than is equal to 4 means x should be less than 5. It is important because for the 4.9, the greatest integer is 4. Now answer will be intersection point of these two intervals. What is the intervals? This is from 1 to infinite, and for here it is the 5 to minus infinite to 5. Means your answer will be x belongs to closed 1 to 5 open. Do you get it? Answer will be from 1 to close 1 to open 5. Student, let's see one more example. You have to find the domain of fx is equal to sine inverse greatest integer x. What will be the domain of this? As we know, sine inverse x function is defined if greatest integer x will lie between minus 1 to 1. Then by using the inequalities, you can easily find your x will be from closed minus 1 to open 2. This is the domain of this questions. Do you get it? Now here is the fractional part function. Fractional part function is represented by y equals to fractional part of x, and the definition of the function is x minus greatest integer x, and it is denoted by this curly bracket. Here this is the greatest integer, and as we know, the value of greatest integer x is less than equal to the x. And if we want to understand the basic property of the fractional part function, then we are going to make a list here. If x lies between 0 to 1, then what will be the value of fractional part function? The value of fractional part function can be obtained by using this formula. As we know, x lies between 0 to 1, the greatest integer x is 0, means your answer is x. If x is lies between 1 to 2, then your answer will be x minus 1. If x is lies between 2 to 3, then your answer of fractional part function is x minus 2. If x lies between minus 1 to 0, as we know, the value of fractional part function will be x plus 1. By observing these values, you can say that fractional part function never be negative. The value of fractional part function is always lies between 0 to 1, and this is the range of fractional part function. And what is the input? Means what is the domain? Domain is real values, means you can put any real number in the function and you can find the value of fractional part function of that values. Suppose we want to check the fractional part of 7.9, then by the definition of this, it will be 7.9 minus greatest integer of 7.9. As we know, the greatest integer of 7.9 is 7. Your answer is 0.9. Now if the value is here minus 3.6, what is the fractional part of it? It will be minus 3.6 minus of minus 3.6 greatest integer. As we know, the value of greatest integer of minus 3.6 is minus 4, means this is plus 4. Your answer will be 0.4. The graph of fractional part function is here. You can observe the graph. From 0 to 1, it is the y equals to x line. From 1 to 2, it is the y equals to x minus 1 line. Similarly, it is x minus 2 line, it is x plus 1 line, and so on. It is x plus 2 line. This is the graph of the fractional part function. Let us see one example on the greatest integer or fractional part function. What is the definition of fractional part function? As we know, it is x minus greatest integer x. Now what is the x? X is greatest integer x plus fractional part of x. Now use this system to solve this equation. Now twice of greatest integer x is equal to greatest integer x plus 2 times of fractional part of x. Now simplify it. Greatest integer x is equal to twice of fractional part of x. Now fractional part of x is equal to greatest integer x by 2. As we know, the value of fractional part x is greater than equal to 0 or less than 1. Now the value of this fractional part is greatest integer by 2. Put here. Greatest integer x upon 2 should be greater than equals to 0 and less than 1. Now greatest integer x should be greater than or equal to 0 and here less than 2. What is the integer between 0 and 2? Between 0 and 2, integer is either 0 or 1. Means greatest integer or integer is either 0 or 1. Now if greatest integer is 0, then what is the value of fractional part of x? By this formula you can check it. If greatest integer x is 0, then you can say fractional part is equal to 0. Now using equation number 1 or your question, what is the value of x? The value of x is 2 times greatest integer x is equal to x plus fractional part of x. What is the value of this? This is 0 is equal to x plus 0. Yes or no? What is your x? X is 0. Means one solution is x equals to 0. Now if greatest integer x is equal to 1, Then applying equation number 2, what will be the fractional part of x? Fractional part of x will be 1 by 2. Now use the value of fractional part and greatest integer in the equation number 1. We can obtain 2 into 1 is equal to x plus half. X will be 2 minus half, it is 3 by 2. Now the solution of this equation is x is equal to 0 and x is equal to 3 by 2. These are the answers. Let us see one more example on greatest integer x. Equation is greatest integer x square minus 5 times greatest integer x plus 6 is equal to 0, and you have to solve it, means find the value of x. Now consider greatest integer x is equal to t. Then what is your equation? Equation will be t square minus 5t plus 6 is equal to 0. Now factorize it. It is the t square minus 2t minus 3t plus 6 is equal to 0. T is common here, t minus 2 minus 3 is common, t minus 2. As we know, the factor of this equation is t minus 2 and t minus 3 is equal to 0, means your answer will be t equals to 2 comma 3. What is the t? T is greatest integer x, means the greatest integer x is 2 or 3. Then you have to find the value of x. What will be the value of x? X lies from 2 to 4. Here is the closed, here is the open. This is the answer, because if we take any values, then the greatest integer of that value will be either 2 or 3. The solution of this question is x belongs to 2 to 4. In the category of transcendental function, here is the logarithmic function. Let logarithmic function like log x base a. What is this? If it is a value takes m, then you can say x is equal to a to power m. And this definition is written here. The logarithmic of a positive number x to the base a is a number equal to the power to which a must be raised in order to obtain x, means x is equal to a to power m. This is the basic definition of a logarithmic function, means if it is given that log x base a is equal to m, then you can write x is equal to a to power m, and if it is written that x is equal to a to power m, then you can say log x base a is equal to m. And it should be noted that when solving logarithmic inequalities, it is necessary to remember the function y is equals to log x is decreasing if a is greater than 0 and less than equals to 1, and it is increasing if a is greater than 1. This is the graph of a function where a is greater than 1, and this is the increasing graph. And this is the graph of the log x base a where a lies between 0 to 1. And if we observe these two graphs, then we can find that log x base a is defined only for x greater than 0, means domain of the log x is from 0 to infinite. By observing the graph, you can see that the value of the function lies between minus infinite to infinite in both the cases, means a range of the log x is lies between minus infinite to infinite. This is the basic important definition of logarithmic function, that their domain is the positive real number and their range is the real number from minus infinite to infinite. Now we are going to discuss some basic properties of the log function. Here are some formula and you have to remember these formulas. Log of x into y at the base a, it is equal to log x base a plus log y base a, where product is positive, means they are of the same sign. Log of x upon y base a is equal to log x base a minus log y base a. Log of x to power alpha base a is equal to alpha times log x base a, where x is greater than 0 because it is the domain of the logarithmic function. Similarly, log x to power 2m base a is equal to 2m log x base a, where it is given that m is the natural number, a is greater than 0 and a is not equals to 1. This system will provide the definition of the logarithmic function. And this is the most important formula, and it is also called as base change formula. Log b base a can be written as log b base x and log a base x. One most important thing is this: if it is given that log of fx base gx, then to define this function, it is necessary that fx should be greater than 0, gx should be greater than 0 and gx is not equals to 1. Why gx is not equals to 1? Because if we written like this, log fx upon log gx, as we know, log of 1 at any base is equal to 0. If gx is 1, then numerator is defined but denominator is 0 because gx is 1. That's why you can say this function does not exist for gx is equal to 1. That's why basic definition of the log function is written here, means log fx base gx is defined only when fx is greater than 0, gx is greater than 0 and gx is not equal to 1. On the basis of base change formula and previous properties, we can obtain other formulas of log function, and they are most important formulas. List of the formulas are here. You can understand it, note it down. This is also an important formula of the log function. And keep in mind, in this case, x and y is here and they interchange their position. Students, remembers these formulas. The formula list is very important to understand the basic of logarithmic function. Now students, on the properties of log, here is the inequalities of the logarithmic function. First property is the definition of log x, as we know very well. If log fx base a is equal to y, then fx is equal to a to power y. This is the important property, or we can say it is the main definition of logarithmic function. On the basis of this equation, you can understand following inequalities. Please remind it, inequalities are here. I am going to brief you about these inequalities. Log fx base a greater than or equal to log gx base a. If base is greater than 1, then sign of inequality will not change. If base lies between 0 to 1, then sign of inequality will change. As we know, in this case, function is the decreasing function. Similar property we can use in the property number 3rd and 4th. Let us see next question. Question is here, and solve this equation. As we know, the domain is x greater than 0. Now simplify it. It is the log x base 2 whole square. You can write like this, plus twice of log base 2 x to power 1 by 2 minus 2 is equal to 0. Simplify it. It is the log x base 2 whole square plus it is the 2 into 1 by 2 log x base 2 minus 2 is equal to 0. Now let log x base 2 is equal to t. Equation will become t square plus t minus 2 is equal to 0. Now factorize it. It will give t plus 2 t minus 1 is equal to 0. Your answer will be t is equal to minus 2 and t is equal to 1. What is the t? It is the log x base 2 is equal to minus 2. X is equal to 2 to power minus 2 means 1 by 4. From here, log x base 2 is equal to 1. X is equal to 2. Your answer will be 2 and 1 by 4. Both answers satisfy the domain. That's why the solution of this equation is x is equal to 2 and 1 by 4. Student, now we are going to study exponential function. A function fx is equal to e to power x is equal to e to power x ln a, where a is greater than 0, a is not equals to 1, and x belongs to real number, is called an exponential function. The graph of exponential function can be listed here. Is first, if a is greater than 1, the graph is like this. If a is lies between 0 to 1, graph is like this. And if a equals to 1, then it is not an exponential function, but you can say it is a constant function, or graph is represented here. Exponential function has a definition that a is not equals to 1, keep in mind. Now students, on the basis of the properties of the exponential function, we are going to solve this easy equation. It is the 3 to power 2x plus 5 is equal to 3 to power x plus 2 plus 2. Now simplify it. It will become 3 to power 2x into 3 to power 5 is equal to 3 to power x into 3 to power 2 plus 2. Now it is 3 to power x whole square into, what is the 3 to power 5? It is the 243 is equal to 3 to power x into 9 plus 2. Now let 3 to power x is equal to t. What is the equation? 243 t square minus 90 minus 2 is equal to 0. Now simplify it. We can obtain the factor t minus 1 upon 9 and t plus 2 upon 27 is equal to 0. What is the t? T is the 3 to power x. 3 to power x is equal to 1 upon 9 and 3 to power x is equal to minus 2 by 27. It is not possible because as we know 3 to power x never be negative. It is not negative. That's why only one solution, 3 to power x is equal to 1 upon 9, or you can say is equal to 3 to power minus 2. It is 3 to power x, means the solution of this equation is x is equal to minus 2. Let us see one more example. Find the domain of fx is equal to sine inverse log base 9 x square upon 4. Sine inverse x is defined if x, or you can say fx, lies between minus 1 to 1, means log base 9 x square upon 4 lies between minus 1 to 1. Now by using the inequalities of the log, you can say x square upon 4 lies between 9 to power minus 1 to 9 to power 1. Now simplify it. X square is greater than equal to 4 upon 9 and less than equals to 36. Now we can take square root on this inequality, then it will become mod x greater than or equal to 2 by 3 less than or equal to 6. As we know, the solution of this inequality is x belongs to minus 6 to minus 2 by 3 union 2 by 3 to 6. This is the answer of this inequality.